Hello everyone, Kamatsu here. In this video I'm going to review this extremely small single board computer. And just to give you an idea on how small this actually is, this is a Raspberry Pi Zero, and this is an Arduino Uno. And in case those don't really give you a good idea, this is a micro SD card. That's how small this thing is. And it runs Linux. So to get to some of the specifications, it has a MediaTek 580 MHz single core CPU with 128 megabytes of DDR2 800 RAM. Its storage is 16 megabytes of SPI flash, and that flash is rated at over 100,000 cycles. Now just to show you up close the device and talk a little bit about the I/O pins. So you can see here on top of the board the MediaTek main system on a chip. This has the 802.11n Wi-Fi radio with 2-stream capability, so up to 300 megabits per second. It has 3 serial ports, 4 analog to digital converters, 1 digital to analog converter, a PCI Express interface, and many other I/O interfaces, as you can see in the diagram. If I flip it over, you can see that my particular device has a Samsung memory chip, which is right here, and this is the GigaDevice SPI flash chip. I'm not entirely sure what that little one is. I couldn't find anything online about it, so we'll just put that back down. So this little single board computer is called the VoCore2. It runs Linux, specifically OpenWRT's distribution of Linux. And there's also a version of this device called the VoCore2 Ultimate. It has an Ethernet port, an SD card slot, a USB-A port, a micro USB port, along with a built-in serial to USB adapter. But today I'm going to just show you the base version of the VoCore2, which is this device. I'm going to take the rest of these things away. Now, some ideas I had for this single board computer would be to build your own smart speaker. You could use the ADC inputs for a solar-powered Wi-Fi connected weather station, for example. This uses fairly low power for what it's capable of, so you could easily run it off of a small solar panel and a battery. You could build yourself an internet-connected thermostat. There's even a display for this device that you could use to, say, monitor security cameras in your house or at your office. Or there's actually a camera module that you can hook up to this device and have it record as a security camera itself. Because it is so small, it can fit into a lot of different projects. That's actually what got me really excited when I saw this. So let's take a quick look at the user interfaces for this single board computer. You can see that I've hooked it up to power and the serial connection for the console. So if we pull up the computer, you can see I'm already connected via the serial console here using PuTTY, and I'm also connected via Wi-Fi to the default access point that it creates. So let's just look at the command line first. You can see by default that it doesn't ask you for a password. That is something that you'll want to address if you put this in a permanent product, especially if other people have access to it. You want to change the settings to be able to lock that down and actually require a password. So if we run this command, you can see this is the VoCore2 running on the MediaTek processor like I talked about. We can also run free to see how much memory it has, which, like I said, it's about 128 megabytes, and storage. So you can see we have about 11.6 megabytes free, and that might seem like almost nothing, but on an embedded platform that is a significant amount of space. Especially with OpenWRT, the binaries are very optimized for storage space, and this is also compressed storage. So when you load an application on here, it's compressed on the fly before it's written to the flash chip, so it actually takes up less space. And that's just a standard OpenWRT feature. You may be familiar with OpenWRT. A lot of people run it on their routers. It is a fairly powerful Linux distribution for embedded devices like this single board computer, which is running off a system on a chip that's designed to go inside of a router. So obviously with command line access, you can do a lot of different things that you could normally do on a OpenWRT system. Once you get this connected to the internet, which is fairly easy, you can download additional applications from the OpenWRT repository. But let's take a look at the web interface for this single board computer. So you just log in here, and you can see pretty much the same output we've already looked at. You can see all the status information, including the PC I have connected and so on, along with the wireless information. By default, it's set to automatically pick an open channel. So you can see it selected channel 6. I don't know why it's not showing the frequency for channel 6 there, but I'm sure that'll be fixed in a later release. And speaking of releases, I do want to mention that upgrading this is very important. There are, of course, a lot of bugs in the firmware that ships with it from the factory by default. I'm sure that'll be resolved in the next batch or something like that. It's really easy to upgrade the firmware. You just go up to System here and Backup Flash Firmware, and you can browse for the image file, which you can actually get from here. And I will include a link in the description to get to this site, which is the creator's website. But you can see I've already downloaded the 2018-0723v.bin, which is the latest firmware at the time of making this video, and I installed it already to this device. So mine actually says OpenWRT snapshot and a bunch of information about the specific build number of OpenWRT. And you'll notice when you get yours, it probably won't say snapshot, it'll say something like Chaos Calmer, which is the base version that this comes with, or at least mine came with, from the factory. So it's a fairly simple process to upgrade, and it takes about 2 minutes, so I would definitely recommend doing that as the first thing you do when you get this thing up and running, is connect to its wireless access point and go through the flash new firmware image process. And just be patient and wait those 2 minutes after you tell it to flash, because it is kind of slow. Remember, it's writing to an external SPI flash chip. But for the most part, that isn't going to really affect the performance of this device, because you aren't going to be doing a lot of storage I/O when using it on a regular basis. So you can see in here that you can configure the wireless connection, so you can add a password to the default access point. You can also put it into client mode and connect to your existing wireless network, which is what I plan to do. That way you can access the device over your existing wireless network with your existing network security, and you don't have to worry about locking this down or switching your laptop or phone or whatever over to this access point to be able to get into this remotely. I'm not going to go through and show you all the different screens in OpenWRT. Feel free to go to openwrt.org and check out all their how-tos and tutorials if you want to learn how the interface works. But you can use the OpenWRT web interface to control all the basics with this device and get it up and running as just a simple router. So for example, if you build up and solder your own Ethernet connection to this, or if you go and buy the VoCore2 Ultimate that has the Ethernet connection already available, you can use this device as a wireless bridge for something that's only wired, which is another nice feature. Another thing you can look up on the OpenWRT website is all of the applications for this device. So for example, you could put a little web server on here, you could put a DNLA server on here. There's a lot of different things that you can do with this platform. There's hundreds of applications available for OpenWRT. Because this is running OpenWRT, those applications can be installed on this single board computer very easily. Now just to quickly talk about pricing, the version I have here is $18 from Ameridroid, and the VoCore2 Ultimate, as you can see, is about $45. And you can see the prices for the screen and the camera there. Ameridroid was really cool and sent me this for free. This is not a sponsored video. I've not been paid to give any kind of review on this. I actually picked this myself from their store to review. I thought it was really cool that a full-fledged Linux system was crammed into this tiny single board computer, and I saw a lot of potential for doing future projects with this, which would mean more videos. So I will have this link to Ameridroid's store in the description. It's not an affiliate link, I don't get anything for you guys buying these. I do think that the base version is a pretty good deal for what it does. The VoCore2 Ultimate is a little bit on the high side on price, and I think that's just paying for the convenience of such a small device. So that's why I'm actually reviewing the base version, which I think is the better deal. It has all of the features built into it. It's only 18 bucks, where, say, a comparable device would be a Raspberry Pi Zero W for $10, but then you also need to buy an SD card, which will probably get you up to that $18 cost because you don't want to go cheap on your SD card. You want to get a quality SD card. So if you like this video, please subscribe to see future videos that I make, and thank you for watching. That's all for now.